What in the world? Okay.
And it's on my
I hope you know what you're doing. Because in the end, you have to.
Honestly, should I have shot?
Alright, guys, let's do a quick recap here. We're not gonna actually solve this problem because I'm making it up on the fly and the answer probably wouldn't make sense. But let's suppose that right now, I can sell 500 math worksheets for $2 each. Okay? I have done some research and I have figured out that if I lower my price, every 10 cents I lower my price, I'll sell 25 more worksheets. Okay? So right now I'm selling 50 or 500. I'm selling 500 for $2. Every time I lower my price 10 cents, I'll sell 25 more sheets. Write an equation for my income. What will my income function look like? Remember, it's how many you sell, so it's the number sold times the price each, right? So how many am I selling? 500, but that is going up in increments of 25? And then the price was 2. It is going down in increments of 10 cents. Does that make sense to everybody? Now, we're not, like I said, we're not going to do it because it probably won't make sense. But at this point, if I wanted to find my maximum income, I would multiply that out. It would be a quadratic, an x squared. I would find the vertex, negative b over 2a, and then go from there, right? So whatever, so if x came out to be 3, then I would lower my price 30 cents and charge $1.70. And I would sell 575 worksheets. Okay, you got that? Okay. All right, one more quick recap from before lunch. These power functions, and we discovered that almost half of our BFFs are power functions. And power functions have very distinctive behavior. So, power functions, something y equals x to a power. If that power is negative, then it's going to behave like this. Because that is, which of your BFFs? 1 over x, which is x to the negative first. So x to a negative, any negative is going to behave like this, okay? Now, what about if, so that's if it's negative. What if it's 1? What does it look like if it's 1? It looks linear, it's just that line. If that power is more than 1, and that can be like, I don't know, 4/3. It can be any number more than 1. You're going to have like a parabola type behavior, curving like that. If it's less than 1, still positive, but less than 1, you're going to have your square root behavior like that. If you put a negative in front of any of those, it simply does what negatives do, flips you across the x-axis. Right? So the shapes are going to stay the same, you're just going to be down here. Got it? All right, let's get back to business then. We're now going to do 18, which they go right down in order. So 18 says, the volume of a circular cylinder with its height is proportional to the square of the radius. Now, earlier, I told you we're writing equations for 2 kinds of variation, direct and inverse. This problem doesn't use either word. Is proportional means direct. So proportional is the same as direct. So when you see that word, think direct variation. Remember, the structure of direct variation is one variable is k times the other one. That's it. That's it. That's all there is to it. The current, oh wait, no. The volume, the current is inversely proportional to the resistance R. Okay, I'm just going down the line here. I know the numbers got cut off, sorry about that. All right, now what's my format? This is my format for direct. What's my format for inverse? Y equals K over X?
Yeah.
So I equals K over R? Now this one, they told me not to use K. For some reason, they want me to use V. This is your constant of variation. They're telling me in this problem that I'm supposed to use V instead of K. That doesn't change a thing, it just means use V instead of K. Charles' law states the volume of a gas varies directly as the temperature. So what's my strategy? These are my two things, volume and temperature. They vary directly. So V equals KT. Energy is proportional to the mass M. Proportional means what kind of variation? I just told you. Direct. So E equals Km. But this is another one where they tell me don't use K, use the constant of variation as C squared. Have you ever heard that formula before? E equals MC squared?
Yeah. Isn't that Einstein?
Uh-huh. All right, the speed of a falling object varies as the square root of the distance. It says it varies. If it doesn't say inverse, that's direct. So E equals K root D. But wait a minute, K is the square root of 2G. So P equals the square root of 2GD. I just put, they told me what to put in for K, so I put it in. Alright. Do we need to do all these? Yeah, no. Alright, let's stop there. And let's go up to the top of the page now, where it says page 196. Determine whether it's a power function. If it is a power function, state the power and the constant of variation. Okay. So let's hold off on that. Let's just figure out if they're power functions. So would you think number one is a power function?
Yes.
Okay, so remember, this is a power function.
Oh, yeah.
X to a power. Problem number one, x to a power. Yes, so that is a power function. How about 2? Yes. How about 3? No. No. A power function is x to the power. That is not 3, so 3 is a no. 4.
No.
That one is really tricky. I think you could make a case for either one of those, but I want to remind you that 13 could be written like this. What is anything to the 0 power? 1. So would you agree that that equals 13? And the power is 0. Now, yes, yes. Now, that does not follow the rules we were talking about before. That would be a horizontal line. Okay, that would be a horizontal line, but it can be considered a power function. How about, now number 5, yeah, notice the way that's written, you guys. They didn't use X this time, they used M. M is to the first power, that is a power function. Think of it as C squared M. That is a power function. Your X is M this time. How about 6? Yep. How about 7? I'm looking at 7 here.
No.
7 is actually a yes.
Yes.
And you kids, I get it, it's hard because you don't know what the variable is. The X in problem 7 is T. It tells me in the directions that C, G, K, and pi are not variables, those are constants. Everything else is a variable. All right, V, yep. Oh, I said V, I meant 8. 9.
Yeah.
9 can be written as I equals KB to the negative 2. And then number 10.
Yeah. Yes. Yeah. Well, yeah. Wait, you gotta yes.
What's our argument? What's our question?
Oh, it said you can make it
Number 10. What's your variable?
You gotta
Your
wait
variable
till
is
the
K.
because it's N.
So this is the same as Y equals N.
Oh.
Your variable is
So it
N.
is. Okay.
This is your variable.
Yeah.
Okay? One more thing to do with these. It says if it's a yes, state the power and the constant of variation. So for number 1, the power is 5 and the constant is negative 1/2.
So we just write that down.
That's what you write down. Yeah, it just says write the power and the constant. So the power would be 5. The power is the exponent, that would be 5. And then the coefficient is your constant, negative 1/2. For number 2, the power is 5/3, and the constant is 9. Number 3 was a no. Number 4, this was a tricky one. The power is 0, and the constant is 13. The power is 0, the constant is 13. For this one, be careful. The power is actually 1, and the constant C squared. That's number 5. Because there's no exponent on it. When there's no exponent, that means 1. Like if you say y equals x plus 2, that power is 1. That's my x, and it doesn't have an exponent, so it's just 1.
What would the
Negative
constant?
C squared.
Oh, okay.
Remember, they told me in the directions, these are numbers, these are constants.
Okay.
So anytime you see it's C, G, K, or pi,
Yeah, I forgot.
yeah.
It's your
All right, number 6. My power is 5.
Constant.
Constant's 1/2 K.
1/2 K.
1/2 K. The whole thing, 1/2 K. Joe, it's gonna be okay. Are we okay, guys? Guys, we okay with that one? All right, D. My power is 2. And my constant is 1/2 G.
1/2 G.
8. My power is 3. 4/3 pi. 4/3 pi is my constant.
Power.
This one's a little tricky.
Power is 2.
Power is negative 2,
Two constant.
negative 2,
Yeah.
and the constant is K.
Would it not be like K over 1?
K over 1,
It's K.
which is the same as K, so that's fine. You can do it right, K over 1. All right, and then number 10, the power is 1, constants M. All right. Are we okay with that? All right, let's look at our notes. We gotta get these two finished up. Here we go. The volume of a gas varies inversely as the pressure. Okay, so stop right there. My two things are volume and pressure. I am told they vary inversely. That would mean V equals K over P. That's my format, because it says inversely. Right, peeps? The volume is 9.2 when the pressure is 163. You okay with that? Can I find K now? Let's go ahead and find K. So K is 9.2 times 163, 1499.6. Find the volume when the pressure is 74.1. But I know what K is, right? So can I find my volume now? See, just one step at a time, how easy that was. So now I'll just type that in.
Wow.
And the answer is about 20.238. And I would put a unit on it, but I didn't put units in here, so. All right, see if you can walk through number 5 yourself. Same way we just did this, see if you can walk through number 5. Or run through it, yeah, skip, I don't care, hop, jump, whatever. I just want to hear some answers. You can actually do this problem several different ways, so I'm okay with however you're doing it,
Okay, that's what I was
as long as you're
thinking.
getting the right answer.
I just don't know what to say. Yeah, same. Oh, well, you can, I just want to. I think it's.
He came with 161. Just look at your clock.
161,
205.
It's 200. That's why I got 2, but
Threw you under the bus, Sam.
he's answering for me.
Do you run up to the nearest 10?
I round it to the nearest thousand, because that's what I do. It would actually be 206.
Or 161 pounds.
All right, so let's hear some strategies. What was your strategy?
What is strategy, Sam? Why do you get it off?
Yeah, let's talk about strategy.
I put it in the 11 after the 13 ounces. I like to put it in the other top.
Okay,
That's me, that happens.
okay.
182 by 11.5, and then I got 13.8, or yeah, and then times that by 13.
So that was Nathan, that was Nathan's idea? Anybody have a different idea? Yep, Grace?
I multiplied 182 and 11.5.
Multiplied 182 and 11.5?
Yeah.
Okay, and then what?
And then we divided 2,093 divided by 13.
Okay, so I'm gonna look at that in terms of the equation. Okay, so if things vary directly, weight should be K times shoe size. That's our formula. So 182 is K times 11.5. So K is found by dividing. So I'm not sure. Did that work, Grace?
I don't really know.
Oh, yeah, I think that would be okay, because 182 over 11.5 equals X over 13. Yeah, so that'll work, because that is gonna be times by 13, yeah, so that's fine, that's fine.
See that like how she did it?
Yeah.
Cash picture.
Please say that.
This had me a little confused, but this makes perfect sense. All right, did everybody get 205.739? Okay? All right, 2.2 is also due on Thursday. Here we go with 2.3. Here we go with 2.3. Now we're starting into the meat of the chapter. We're going to be graphing polynomials, okay? Now, I'm going to give you one fundamental piece of information right now, and you're going to remember this forever and ever. If a polynomial has even degree, and what I mean by that is it's x squared, or x to the 4th, or x to the 6th. If a polynomial has even degree, it will be up, or down, depending on whether you have a negative in front or not. So the normal even behavior is like a parabola, x squared, up. That is the normal even behavior. 4th degree, 6th degree, 12th degree, that's how it will behave, up. If you put a negative in front of it, then it will be down. It will turn it upside down. That's how evens behave. Okay, this is going to be important because you're going to be graphing some crazy things and you need to know where to start and end that picture. So if it's x to an even power, and behavior is up, or down, depending on a negative. If it's odd behavior, odd degree, so in other words, if it's something like y equals x to the 1st, x to the 3rd, x to the 5th, then its behavior is down, up. Think of a line. Think of your linear function. Doesn't it look like that? Think of your cubing function. It looks like that. Odd behavior starts down, ends up. That's how odds act. Unless you put a negative in front of them, and then they start up and down. Okay? You guys, that's fundamental. Even and behavior, odd and behavior. Okay? Now, get your calculator out, and we are going to use a standard window. So zoom 6, and we're going to graph the first function there, A. So go ahead and just keep the parentheses plus 3, x plus 1. I'm not sure why there's so much talking. You should all be pressing buttons and hit graph. And do you see a nice little squiggly?
I do.
Okay. And if you're really paying attention, you'll notice that it crosses the x-axis at -2, or no, -3, -1, and +2.
Yep.
Interesting, look at the problem, you're interested, okay? All right, now clear that one out
Should we draw
and
it?
type in the next one. So type in the next one, x plus 3, x minus 2 squared. Now, where did that one touch the x-axis?
-3.
At -3 and 2?
Well, yeah, it didn't go through.
But it, yeah, what's different?
It went to the 0.
It bounced at 2.
Yeah.
And why did it bounce at 2? Because that factor is squared. And what do squares look like, you guys? So when you build a square into your polynomial, it's gonna bounce, just like a parabola bounces. All right, last one, do you see?
It's not
Now, what does it do? You see what Sam did? He said, what's that? It squiggles through 2.
Yeah.
Now, why did it squiggle through 2? Because that's what cubes do. Cubes squiggle.
Wait.
We know that, yeah.
This one squiggled at 2 because that's where it crossed. That's where its 0 was.
He's not supposed to do that.
That is not
It squiggled through. Okay, so now listen, I know we've covered a lot of ground, but tomorrow we are going to start sketching these things without our calculator. So what are two things? Two things we gotta remember. We gotta pay attention to the end behavior. Are we even or odd? And then we have to pay attention to whether our factors are squared or cubed or plane or whatever. Right? Yes. All right. Want to remind everybody that 1 week from today is like the best day ever. Math will be great.
Tuesday, right?
Okay. You gotta be in your seat at 8.
Oh, that's it.